Alright, let's start. Number 8. The Goliath Tracked Mine. In 1942, engineers at Borgward in Bremen unveiled a weapon that looked, at first glance, almost absurd. It was roughly the size of a bathtub, moved at a slow walking pace, and carried no crew. What it carried instead was up to 100 kilograms of high explosive, wired to detonate on contact. German army officials called it the Leichter Ladungsträger, the light charge carrier. The soldiers who encountered it on battlefields from Kursk to Warsaw called it something else entirely. They called it the Devil's Sled. Before the Goliath, destroying a fortified enemy position meant sending men forward under fire, a calculation of flesh against concrete that commanders had accepted as the brutal arithmetic of war. Engineers had long imagined a machine that could remove the human body from that equation, but the technology to build one reliably had never existed. By 1942, miniaturized electric motors and lightweight steel construction made the concept viable. German High Command approved production immediately, and the Borgward factories began turning them out in the thousands. The Goliath came in two variants. The SDKFZ-302 ran on electric motors and carried 60 kilograms of explosive. The SDKFZ-303 used a petrol engine and packed a heavier payload of 75 to 100 kilograms, enough to destroy a tank, collapse a bunker, or clear a trench line. An operator guided the machine from up to 650 meters away, using a joystick connected by a thin 3-strand control cable that spooled out behind the device as it moved. The concept was genuinely terrifying in its simplicity. More than 7,500 Goliath units were produced across the war, and they were deployed at Kursk in 1943, at the Anzio beachhead in 1944, and throughout the brutal street fighting of the Warsaw Uprising. Their tactical record was mixed. Allied soldiers quickly discovered that cutting the thin control cable with a rifle shot or wire cutters rendered the machine instantly harmless. The electric variant was also slow, underpowered, and expensive to manufacture. Wehrmacht reports from the Eastern Front frequently noted operational failures. What the Goliath lacked in battlefield effectiveness, it supplied in philosophical consequence. Here was the first mass-produced remote killing machine in history, a device engineered specifically to remove the human being from the act of destruction. It failed on most of the battlefields where it was deployed. But the idea it carried, that lethal force could be delivered remotely, mechanically, without a soldier present, did not fail with it. That idea survived the war and became the foundation of every unmanned weapons system built since. Number 7. The Mistel composite aircraft. In the spring of 1944, Allied reconnaissance pilots photographed something over occupied Europe that their intelligence handlers initially struggled to classify. A German fighter aircraft appeared to be physically attached to the top of a bomber. The two fused together in flight like a creature from a fever dream. The image was not a trick of light or a printing error. What the cameras had captured was the Mistel, the German word for mistletoe, a weapon that combined two aircraft into a single flying bomb of catastrophic potential. Conventional bombing in the Second World War was an exercise in imprecision. High-altitude raids dropped thousands of tons of ordnance in the general direction of targets, accepting that most bombs would miss. For heavily fortified installations, concrete-reinforced submarine pens, hardened command bunkers, and major bridge structures, conventional bombs often failed to penetrate the necessary depth to cause structural damage. German engineers at the Luftwaffe's development division believed they had found a solution, and in 1943, they began converting obsolete aircraft into something the world had never seen. The lower component of the Mistel was typically a gutted Junkers Ju-88 bomber, its crew compartment replaced entirely with a massive hollow-charge warhead weighing 3,500 kilograms. Sitting on top, connected by a rigid steel cradle, was a Focke-Wulf FW-190 or Messerschmitt Bf-109 fighter with a living pilot. The pilot flew both aircraft together to the target area, aligned the lower aircraft precisely at the objective, then released the coupling mechanism and flew the fighter clear. The unmanned Ju-88 continued on its locked trajectory and detonated on impact with devastating force. Missile combinations entered operational service in 1944 and were used against Allied shipping in the English Channel and against bridges over the Oder River, as Soviet forces advanced from the east. Their most ambitious planned deployment was Operation Eisenhammer, a Luftwaffe scheme to use a fleet of missile composites to destroy the Soviet Union's major power-generating stations east of the Ural Mountains. The plan was abandoned in early 1945 as the Allied advance consumed the airfields needed for the operation's launch. When a pilot climbs into a cockpit bolted to the top of 3.5 tons of shaped explosive, hand flies that assembly to a target, and releases it at the last possible moment before turning away, the line between precision weapon and controlled catastrophe becomes extraordinarily thin. The missile was operational before guided missiles existed, filling that gap with a method that was ingenious, calculated, and deeply unsettling in its intimacy. A man did not fire this weapon from a distance. He delivered it personally, by hand, to within meters of the point of detonation. Number 6. The Fritz X guided bomb. On September 9, 1943, the Italian battleship Roma was sailing under Allied escort in the Mediterranean, 25 kilometers south of the Strait of Bonifacio, when 2 explosions tore through her hull in rapid succession. The first detonated near the aft engine room. The second penetrated the forward ammunition magazine. Roma rolled hard to starboard, broke apart amidships, and sank within 20 minutes. Of her crew of 1,049 men, 393 were killed. The ship had not been struck by a torpedo or a conventional bomb. It had been hit by something that had never been used in combat before. The weapon that killed the Roma was the Fritz X, formerly designated FX-1400, developed by Dr. Max Kramer at the Deutsche Versuchsanstalt für Luftfahrt, Germany's aviation research establishment. Kramer had been working since the late 1930s on a simple but radical premise that a bomb dropped from altitude could be steered to its target by a human operator watching it fall. The Fritz X weighed 1,570 kilograms, carried a hardened steel penetrating nose capable of punching through 130 millimeters of armor plate, and was fitted with a radio receiver linked to small spoiler surfaces on its tail fins. The operator aboard the releasing aircraft used a Kale transmitter to send directional corrections to the bomb as it fell, watching through a Strasbourg optical sight and adjusting its path in real time. The system was primitive by later standards, but it worked with devastating reliability. The bomb's first combat use came on August 29, 1943, when Fritz X weapons were dropped against Allied warships off Salerno. In September alone, they severely damaged the American cruiser USS Savannah and put the British battleship HMS Warspite out of action for months. Allied forces responded by developing jamming systems that disrupted the Kiel-Strasbourg radio guidance, and German crews were forced to fly lower and slower to maintain visual contact with the falling bomb, making them increasingly vulnerable to fighter interception. By mid-1944, the tactical effectiveness of the Fritz X had been substantially degraded. Its operational window was relatively narrow, and it never achieved the strategic impact its designers had envisioned. The Allies suppressed detailed analysis of the weapon in public accounts, partly to deny Germany intelligence on the effectiveness of their jamming countermeasures. Every precision-guided munition dropped in every conflict fought since 1945 traces its conceptual lineage back to Max Kramer's radio-controlled bomb and the Kiel-Strasbourg guidance system that directed it. The Fritz X was not a curiosity or a technical footnote. It was the moment warfare changed permanently, the point at which a human operator first guided a falling weapon to a specific point on a specific vessel from a moving aircraft kilometers away. That the weapon that inaugurated the age of precision killing has been largely erased from mainstream historical memory is not an accident. It is a consequence of how uncomfortable that origin story actually is. Number 5. The Oka, Japan's human rocket bomb. In the spring of 1945, American sailors aboard vessels operating in the waters around Okinawa began reporting a new sound. It arrived before the aircraft was visible, a rising mechanical shriek that grew from nothing to overwhelming in seconds. Conventional kamikaze aircraft could be tracked, intercepted, and sometimes shot down before they reached their targets. Whatever was making this sound could not. By the time it was audible, it was already too close. American naval intelligence identified the source in April 1945, and what they found in captured Japanese documents disturbed them profoundly. The weapon was the Oka, Japanese for cherry blossom, officially designated MXY-7 by the Imperial Japanese Navy. It had been conceived in 1944 by Ensign Mitsuo Ota, a transport pilot who submitted his proposal to the Yokosuka Naval Air Technical Arsenal, with the conviction that a purpose-built manned flying bomb would be far more effective than converting conventional aircraft to suicide roles. The Yokosuka engineers agreed. They designed a sleek, rocket-powered glider with a 200-kilogram warhead packed into its nose, room for a single pilot in a cramped cockpit, and no landing gear. It was not designed to return. The Oka was carried to the target area, slung beneath the belly of a Mitsubishi G4M bomber, known to Allied forces as the Betty. The carrier aircraft would approach as close as possible before releasing the Oka, at which point the pilot ignited 3 Type 4 Mark I solid fuel rockets and guided the weapon into its terminal dive. In the final seconds, the rockets accelerated the Oka to approximately 1,000 kilometers per hour, making it the fastest aircraft in the Pacific Theater, and essentially impossible to intercept with the fighter technology available in 1945. The pilot could see the ship filling his windscreen as he arrived. USS Mannert L. Abele became the first vessel sunk by an Oka on April 12, 1945, struck during the Battle of Okinawa, and destroyed so rapidly that her crew had almost no time to abandon ship. Several other American vessels were damaged in subsequent attacks. The program's Achilles heel was the carrier aircraft. The slow, heavy Betty bombers were extremely vulnerable to American combat air patrols, and many were shot down before they could release their Oka payloads. Of 852 Oka produced, the majority never reached their targets. The Oka pilot was not simply a man who chose to die. He was a man who chose to be sealed inside a rocket, detached from his carrier aircraft at altitude, and to spend his final minutes accelerating beyond any speed a human being had previously experienced. In combat, alone, with no instrument of escape, with nothing left in his role except to steer. American sailors who survived Oka attacks described the sound of its approach as something that lived with them for the rest of their lives. What does it mean to build a weapon whose defining characteristic is the willing death of the man who operates it? Japan built 852 of them and considered building thousands more. Number 4. The Sturm Tiger, the bunker that moved. When it appeared on the streets of Warsaw in August 1944, soldiers on both sides of the barricades stopped. It was not recognizably a tank in any conventional sense. It was massive, almost square in profile, with a barrel so wide a man could have climbed inside it. German army engineers had spent 2 years solving a specific problem: how to destroy fortified urban positions without exposing infantry to the catastrophic casualties of close-quarters assault. What they produced was the Sturmreserwagen 6064 MIT 38 St. RW61, which history would call the Sturm Tiger, and it was unlike anything that had fought in a city before. Standard German tank doctrine in 1943 called for armored support in urban operations, but conventional tank guns fired relatively small caliber rounds optimized for penetrating armor rather than destroying structures. The Wehrmacht's experience at Stalingrad had demonstrated with brutal clarity that fighting through a city building by building was ruinously expensive in human lives. A heavier solution was needed. Rheinmetall engineers proposed mounting a 380mm naval rocket mortar, originally designed as a submarine depth charge launcher, onto the hull of a Tiger I tank. The Waffenamt approved the conversion program in 1943. Each Sturm Tiger carried the 380mm Raketenwerfer 61, a weapon that fired rocket-propelled shells weighing 345 kilograms, each containing 125 kilograms of high explosive. A single round could collapse the load-bearing structure of a multi-story building, or reduce a reinforced concrete emplacement to rubble. The effective range was approximately 4,600 meters. Loading each individual shell required a crane or hoist mounted on the vehicle's exterior, and the crew of 7 could manage a sustained rate of only a few rounds per hour. 18 units were produced in total, a small number that belied the weapon's impact. The Sturm Tiger's combat debut came during the Warsaw Uprising of August 1944, when Polish Home Army fighters had fortified residential districts across the city against German suppression forces. The Sturm Tigers did not fight the Polish fighters directly. They fired into the buildings the fighters occupied, bringing down entire structures with each round. They were deployed again during the Ardennes offensive in the winter of 1944 and 1945, and in the defensive battles of early 1945 as Allied forces crossed the German border. In each deployment, their effect on structures was total, and their effect on anyone inside those structures was the same. Only 18 were built, and the Sturm Tiger appears in few standard histories of the Second World War. But in Warsaw, across 63 days in the late summer and autumn of 1944, the combined weight of German suppression, including these weapons, killed an estimated 200,000 civilians. The Sturm Tiger was not designed to defeat an army. It was designed to destroy buildings with people inside them, to make the calculation of urban resistance impossible by removing the structures that made resistance viable. The silence around it in mainstream historical accounts is not a gap in the record. It is a decision about what we are comfortable remembering. Number 3. The Carl Gerat, God's Artillery. In June 1941, the Soviet garrison holding the Brest-Litovsk fortress complex on the Bug River looked up from their positions and saw something moving on the tree line that their military training had given them no framework to process. It was too large and too slow to be a vehicle in any category they recognized. It moved on tracks, but it was the size of a small building. At its center was a barrel so wide it dwarfed everything around it. The German army had brought something to Brest-Litovsk that had never been seen on a battlefield before, and when it fired for the first time, the ground shook for kilometers in every direction. The weapon was the Carl Gerat, officially designated Gerat 040 by the Wehrmacht, designed by engineers at Rheinmetall under the oversight of General Karl Becker, head of the Army Weapons Office, whose name the weapon quietly bore. 6 self-propelled siege mortars were produced between 1940 and 1941, and each was given an individual name: Adam, Eva, Thor, Odin, Loki, and Zeus. The naming was not incidental. These were not vehicles. They were, in the conception of the engineers and commanders who built them, forces of nature given mechanical form, weapons on the scale of myth. The Carl Gerat in its primary Gerat 040 configuration carried a 600mm smoothbore mortar barrel. Its shells weighed up to 2,170 kilograms, heavier than a fully loaded family car, and were fired on trajectories designed to bring them down nearly vertically onto fortified positions, maximizing penetration of reinforced concrete roofs. The complete system weighed approximately 124 tons and required a dedicated rail network and specialist transport battalion to move between operational theaters. A firing cycle took approximately 10 minutes from round to round, accounting for the extraordinary weight of each individual shell. The Carl Gerat was used at Brest-Litovsk in 1941, at the prolonged siege of Sevastopol between 1941 and 1942, during the Warsaw Uprising in 1944, and in the final defensive battles around Budapest in 1944 and 1945. At Sevastopol, the weapons were credited by German after-action reports with destroying fortifications that conventional artillery had failed to reduce after months of bombardment. Soviet engineering assessments captured after the war confirmed that several key defensive positions at Sevastopol had been structurally destroyed from above by plunging fire of a caliber for which their designers had made no provision. 6 machines, named after gods, moved across Europe on their own tracks, each one capable of dropping a 2-ton shell onto a fortress from several kilometers away. Almost nobody outside specialist military circles has ever heard of them. The Carl Gerat does not appear in most popular histories of the war's artillery campaigns, does not feature in the museum collections that tourists visit, and is rarely discussed even in academic treatments of German siege warfare. What we choose to forget about the machinery of the Second World War says as much about us as what we choose to remember. The question is, why these particular machines, of this particular scale, were the ones we decided to set aside. Number 2. Schwerer Gustav, the largest gun ever built. In the spring of 1942, preparing to fire the weapon at the besieged Soviet city of Sevastopol required more than 2 weeks of continuous labor by a workforce of approximately 2,500 soldiers, engineers, and support personnel. A specially constructed double rail track had to be laid to carry it to its firing position. A second track ran parallel to allow a crane to service the barrel from above. The barrel itself was 32 meters long. When Schwerer Gustav, Heavy Gustav, fired its first operational round in June 1942, the sound was reported to have been heard 40 kilometers away. It was the largest gun ever built, and almost no one alive today knows it existed. Schwerer Gustav was commissioned at Hitler's personal directive and designed by engineers at the Krupp AG Works in Essen, the same industrial complex that had supplied German artillery through the First World War. A sister weapon, named Dora, was produced alongside it. The weapons were intended to address a strategic problem that had defeated German planners in 1914. The fortifications of the French Maginot Line and the hardened Soviet defensive networks in the east were designed to withstand any artillery then in existence. Krupp's engineers were told to design something those fortifications could not withstand, and they did. Gustav's caliber was 800 millimeters, the largest bore ever used in the history of combat artillery. Each high-explosive shell weighed 4,800 kilograms. Each armor-piercing shell weighed 7,100 kilograms, with a propellant charge of 2,240 kilograms required to achieve a muzzle velocity of 820 meters per second and a maximum range of 47 kilometers. The weapon sat on 2 parallel rail bogies and required its own permanent Luftwaffe fighter escort when stationary, because an immobile target of that scale and strategic value could not be left undefended against Soviet air attack. At Sevastopol in 1942, Schwerer Gustav fired 48 shells across its operational deployment. One of those shells penetrated 30 meters of earth and reinforced concrete to destroy a Soviet ammunition magazine that had been constructed beneath the waters of Severnaya Bay, a target that German planners had considered effectively immune to conventional bombardment. The impact of that single round was verified by post-battle Soviet damage assessments captured later in the war. In terms of raw penetrating power delivered to a single point, no weapon in human history before or since has matched what that shell accomplished. Schwerer Gustav fired 48 rounds in its entire operational existence. It cost the German war economy resources equivalent to tens of millions of Reichsmarks, required a workforce the size of a military battalion simply to operate, and destroyed a magazine buried beneath a bay that no other weapon could have reached. It exists today in almost no standard history of the Second World War. Some things are too enormous, too colossal in their implications about human ambition and industrial violence, to fit comfortably into the story we have agreed to tell about that conflict. Schwerer Gustav is the most complete proof of that principle. What comes next makes even Gustav look like a beginning. Number 1. The V3 cannon, the weapon designed to end London. In 1943, inside a chalk hillside at Mimoyekes in the Pas-de-Calais region of northern France, thousands of forced laborers began excavating a tunnel complex 5 stories deep. They worked under armed guard, without adequate food or medical care, and many of them died in the excavation. They did not know what they were building. The German engineers who designed it called it Hochdruckpumpe, high-pressure pump, a deliberately meaningless name intended to obscure its purpose from Allied intelligence. When British intelligence analysts finally identified the site and understood its function in 1943, the assessment that reached the War Cabinet in London described it as the most dangerous construction project they had encountered in the entire war. The weapon was the V3, the third of Nazi Germany's Vergeltungswaffe series, the vengeance weapons, developed by engineers at Saar-Rüchling and championed through the approval process by Albert Speer, Hitler's Minister of Armaments. The V3 was a supergun, a barrel 130 meters long sunk at a fixed angle into the hillside at Mimoyex, with subsidiary propellant charges positioned at intervals along its length. As a shell traveled up the barrel, each successive charge ignited in sequence, accelerating the projectile in stages toward a muzzle velocity sufficient to carry it 165 kilometers from the French coast to central London. The multi-stage acceleration principle was revolutionary. Nothing remotely like it had been built before. The planned installation at Mimoyeques called for 25 operational barrels, each capable of firing 300 shells per hour. At full operational capacity, the facility would have delivered 7,500 shells into London every single hour, continuously, without pause, without the weather limitations that grounded conventional bombers, and without any defensive countermeasure available to the Allies in 1944. Anti-aircraft guns could not reach it. Fighter aircraft could not locate a fixed underground installation and destroy it through conventional means. The weapon did not fly. It sat inside a French hillside and simply fired, relentlessly and systematically, at a city 165 kilometers away. RAF 617 Squadron, the unit that had breached the Ruhr dams in 1943, was tasked with destroying the Mimoyeques facility before it became operational. On July 6, 1944, 617 Squadron's Avro Lancasters dropped tallboy deep penetration bombs, each weighing 5,400 kilograms, onto the site. The earthquake effect of multiple tallboy impacts collapsing the tunnel network rendered the facility permanently non-operational. A smaller V3 installation at Lempaden in Germany subsequently fired approximately 183 shells at the city of Luxembourg and the town of Trier in late 1944 and early 1945, providing the only documented record of the weapon in actual use. Those shells killed 10 people and wounded 35. They were a fraction of what the weapon had been designed to deliver. The tunnel complex at Mimoyex still exists beneath those chalk cliffs in northern France. You can visit it. The shafts are intact, the excavations preserved, the geometry of what was almost built still visible in the rock. At full operational capacity, it would have fired 7,500 shells into London every hour. Not every day. Every hour. There was no defense. There was no evacuation plan adequate to that rate of destruction. There was no version of that weapon becoming operational that did not end with London becoming uninhabitable, systematically, on a mechanical timetable, until whoever survived decided to surrender. We do not discuss the V3, because to discuss it honestly is to confront something that does not fit the story of a war that was won before the worst thing could happen. The tunnels at Mimoyeques are the most important monument to the Second World War that almost nobody has ever visited, because what they memorialize is not what occurred, but what came within months of occurring. And that distinction is the only reason the history we know exists at all. If you want to see more videos like this, click the video on screen now and make sure to subscribe.